Good morning, and thanks for coming to my talk. Again, I'm Brandon Baker, lead security engineer for Windows virtualization, and I get to work on the Microsoft Windows hypervisor. So about 5 years ago, I interviewed at Microsoft, and I interviewed with a couple different groups. One of the groups I interviewed with talking about things about ring -1 and new instructions to the x86 instruction set. And I knew I was hooked at that point. So that's what this talk's going to be about. Virtualization is some pretty exciting stuff. It's really useful for getting work done. And we're building virtualization into Windows and Windows Server. So the talk today is going to be on a couple points. The first one is, why are we building a hypervisor, or why are we building a hypervisor into Windows? What's so cool about hypervisors? The next thing is going to be kind of a quick background and some architecture on Windows Server virtualization and the hypervisor. I could spend hours just talking about the architecture of the hypervisor. We don't have time for that today. But if you look on the conference CD, the slide deck that's on there has a lot more information on the architecture of the hypervisor and Windows Server virtualization. And then the bulk of the talk, I'm going to be talking about the security characteristics of what we're building. And a lot of this is going to be generalized to virtualization, applying across the board. And other things are going to be very specific to the technology that we're building. By and large, we're seeing more and more virtualization all the time. Like I said before, it's just a really useful way to get work done. But as security professionals, we have to think about, as we're securing systems or looking at ways to find vulnerabilities in systems, what's the impact on virtualization on the security community? The next area is going to be around deployment considerations. If you're thinking about using virtualization or you're looking at this technology, what are some best practices for implementing and deploying virtualization? What are the security concerns that virtualization brings with it? Solves a lot of business problems. That's great. Solves some technical and security issues. That's great. But in and of itself, it also has its own security issues that are really important to keep in mind. And then finally, going to have a few things to say on some future directions in virtualization and just some general topics around the industry on where virtualization is heading. I'd like to ask, if you can, maybe hold the questions to the end. I'm going to try to leave some time to go through and take questions at the end. I really like to talk to people one-on-one or a few people around a whiteboard too. So if you see me through the rest of the conference and want to talk in more detail, grab me. I'll try to go over to the Microsoft booth. I assume there's a Microsoft booth. I've not ever been to it before. This afternoon. So if you want to stop by and talk more, that's great too. All right, so why a hypervisor? Why am I so excited about a hypervisor? Why do I think they're so kick-ass? I mean, the first point is we're talking about something that's a thin, low-level microkernel, right? It runs below the operating system, right in between that interface at the hardware OS interface. And, us OS and kernel geeks, the lower you get, closer you get to hardware, the cooler things get. But more importantly, it addresses an issue with virtualization and software virtualization today. In order to make things like virtual PC and virtual server and maybe VMware Workstation, these software virtualization techniques effective and work correctly, we have to do kind of a mechanism we call ring compression. Well, in moving over to hardware virtualization in a hypervisor, we eliminate that point of complexity. And this also means that with hardware virtualization in a hypervisor, we can run an operating system without any modification at all. In order to make ring compression work correctly, we have to kind of modify or change up some bytes in the operating system on the fly so it doesn't know it's being compressed, doesn't know it's being virtualized in the way that it is. With the hardware virtualization in a hypervisor, we get to run an OS essentially raw, bare inside the metal, inside of a partition. And as we're running everything as partitions, we get some additional defense in depth, and I'll talk about that some more later on. And by and large, we think that this model, this architecture of a hypervisor is the best way to use the hardware that Intel and AMD are putting out today and leverage the future hardware investments, some of which we'll talk about at the end as well. And finally, I think this is really kind of the right way to address scalability. In the future, as we're looking at systems running large numbers of virtual machines on systems with large number of CPUs, we think a hypervisor approach is really the right way to address scalability. So what is the hypervisor and what's the system it's a part of? This has been a project at Microsoft codenamed Viridian. And we're really talking about full fidelity machine virtualization. Right? This isn't like software virtualization. This isn't like, say, maybe like the Common Language Runtime or the Java VM, which is an abstract virtual machine. We're talking about creating a virtual machine that's the full x86 PC. This is something that we're building into Windows. This will be a component of Windows Server 2008. The Windows Server virtualization component will be available within 180 days of Server 08 RTM. It's kind of the realities of dealing with an evolving hardware platform and also an evolving OS platform. And finally, Windows Server virtualization installs as a role in Server Core. Server Core is some new technology that's built into Windows Server 2008 that lets you install basically just the bare minimum of the OS. Very little more than is necessary to do a role, in our case, virtualization. Ian McDonald is giving a talk on this tomorrow, so if you're interested in this technology more, you can go to that. All right. So the system is comprised of three major components. The first one's a hypervisor, but it's not the only thing. We also have a virtualization stack, and we have a collection of virtual devices. As the system is hypervisor-based, we take advantage of and we also require the hardware virtualization extensions that are present in Intel VT and AMD SVM hardware. Basically, most of the newer processors that have been available for the last 9-12 months. We are supporting x64, 64-bit hardware only. This is a server product, server market. Having a 32-bit hypervisor really would constrain us on the guests we can run. So what we're saying here is this does require 64-bit hardware, and then the operating systems that we can run on top of it, anything. 64-bit, 32-bit, 16-bit if you want to run DOS still on a really big piece of hardware. So kind of to give some of the history of the background here on the old way of, I mentioned ring compression before and what that was. So software virtualization systems like Virtual Server, running an operating system, essentially the host OS. We've got ring 0 for the kernel, ring 3 for the applications that are running. And when you want to activate virtualization, you need some sort of virtual machine monitor. And under software virtualization systems, these typically run essentially alongside with or cooperatively with that kernel, inside the same address space. And then when you want to run a guest operating system, it runs it essentially as an application, basically. You can almost think of it like that. And it puts that guest OS kernel into ring 1. Right? And then the guest applications themselves can still run as ring 3 sort of native applications. But in order to make that operating system work correctly, we have to make it believe that it's running a ring 0. So any instructions that it does that try to determine or would be able to see that, we have to intercept and do runtime translation, binary translation, on that operating system, essentially modifying its code bytes so that it sees ring 0, even though it's running a ring 1. And that's a complexity point. From a security standpoint, complexity is often the enemy of security. While that works, it works great. It's something that is a challenge and something that would be nice to kind of get rid of. So now let's talk about Windows Server virtualization, hardware virtualization, a hypervisor. Right? I'm going to step this through to introduce the components and also essentially talk about them in boot order on Server 2008. So kind of at the beginning of time, we have the kernel. The kernel is just booted on this server hardware. Pretty early on, the kernel loads device drivers. And what we're saying now is that one of those device drivers is the hypervisor. Right? So really early on, the OS launches the hypervisor essentially underneath itself. This now puts that root operating system into a partition. Right? So it's kind of hoisted itself up, launched the hypervisor underneath. And we're able to do this because of hardware virtualization. Now the rest of the operating system comes online. If this is server core, it's really just a foundation of Windows and very little more than what's necessary to run virtualization. In this case, we have these collection of virtual devices. The virtual devices interface with the real device drivers on the system to provide direct or indirect emulated device access for guest operating systems. And then we have some user mode components. And this is that virtualization stack, sort of that third piece of Windows Server virtualization. The virtualization stack has a management service that provides and exposes a WMI interface. The WMI interface allows you to do things like manage, start, stop, launch VMs remotely. Microsoft System Center will be supporting this so you can deploy and manage really large, complex sets of servers with lots of virtual machines. And if you can imagine, if you have a data center of 1,000 physical machines, each running dozens of virtual machines, the management space on that explodes pretty quickly. And then now when we want to run a guest, a virtual machine, we launch what we call a worker process. Right? This is a user mode process that contains a virtual or an emulated motherboard and a collection of emulated devices for a guest. So now we'll bring the guest into existence, and it runs as a separate partition. But the interesting thing here is the guest kernel, the guest OS, also runs in ring 0. You know, when I mentioned ring -1, a hypervisor down in monitor mode, while it's convenient and kind of interesting to think of it that way, actually everything here is actually now a partition. The root, the OS that was there initially is in a partition. Each of the guests is a partition. The hypervisor itself is really effectively just another partition. It just happens to be a specially privileged one, a monitor mode partition. And there are control structures. On Intel, they're called the VMCS. On AMD, it's the VMCB. It's a VM control structure that says what things that partition is able to do. What hardware can it touch? What instructions can it execute? For our hypervisor, we do expose it up to a guest. So we have a well-defined interface that a guest operating system can query to say, well, what am I running on a hypervisor? Which version? Whose is it? The reason we do that is, while we can run an operating system native without modification, that's great. But there's certainly cases where it makes sense for that operating system to know that it's run in a virtual environment so it can do things a little bit more optimally. So we call these guest OS enlightenments. One of the things and another component of Viridian here is something we call VM bus. It's a virtual machine bus. This provides an optimizer direct path from a guest OS into that root partition. Okay. And another thing the guest OS can load are virtual service clients, VSCs. And a VSC has a direct way to talk to a corresponding VSP, like for storage or for network, across VM bus. And VM bus, again, it's a shared memory transport so that you have certain physical pages which are mapped to both the guest and the root. We have one set of VM bus per guest, so the guests don't share VM bus connections. There's a one-to-one from the parent to each child operating system, root to guest. And through this mechanism, we don't have to essentially interrupt or intercept into the hypervisor every time a guest OS tries to do some device access. An example of this might be trying to do a write out to an IDE controller. If an operating system is not enlightened, it's going to try to do a lot of I/O instructions, ins and outs.